Our speaker today is Brandon Zuppardo. Brandon is president of Aztech Reliability LLC and is a subject matter expert in alignment, level 2 vibration, level 1 ultrasound with over 13 years in maintenance and reliability experience. Aztech Reliability LLC is based out of Louisiana, offering only the highest quality products for laser shaft alignment, condition monitoring, and ultrasound, as well as providing high-level training and support to maintenance and reliability professionals. All right, everyone, you're here today for Give Soft Foot the Boot, Discover the Hard Facts. Brandon, take it away.
Okay, great. Thank you so much, Robin, for the intro. Also like to thank Fluke Reliability for the opportunity to present today. Let's jump right into it on our agenda here. Just note this presentation is only going to be it's consisting of maybe 10 slides here. For me, I'm more of a field, hands-on type of guy. So unfortunately, we can't do hands-on in this presentation. So we will be doing a live presentation during this webinar as well. So quickly to go through the agenda here, what we'll be covering. First, we'll define what softfoot is and give an understanding to help visualize what it looks like in the field. And then also the types of softfoot. There are 4 different types. We'll identify each type and what each type will look like on your machine. We'll then look at how softfoot can cause alignment issues, as well how it can harm your machines and its parts. Next, as mentioned, we'll be doing a live demonstration on how to check for softfoot. And in that demonstration, we'll also show you and apply a proven procedure on how to correct for that softfoot. And then lastly, we'll talk about the importance of softfoot and how it can improve your machinery's health. So diving right into it, what exactly is softfoot? This is kind of the basics here. But softfoot occurs when there's, a gap between the machine foot and its base. This could be because, maybe you don't have enough shims underneath your foot, your base isn't flat, but if you visualize it, there's a gap underneath the foot. And the problem really occurs when the foot is tightened down to the base. So this causes distortion, right, in the frame of the machine, basically putting that frame in a bond. And so when the frame is distorted, not only does the frame get distorted, but it also causes parts and components inside the machine to distort, and this then causes consequences. And so what we say is the technical definition here for softfoot is actually internal misalignment. Right? So to understand and visualize softfoot, we typically will go to this 4-legged chair example, which is pretty common here. So the 4 legs on the chair, they act just as if you see the picture of the motor here, the 4 legs act as the 4 motor feet. So if one leg on that chair is too high or short, so to speak, when you sit in a chair, obviously it rocks, right? So when you sit in that chair, right, if you're sitting in a restaurant, that chair's rocking. What we do is we use our brain and we think, okay, well, how do we stop the rocking on this foot? And when we think about it, we don't take those sugar packets or napkins off the table and stick it under multiple feet. We can simply put it under one foot and that will stop the rocking. So we kind of apply this in the real world with machinery and softfoot. And so the procedure we'll show you today in just a little bit, we'll give a real good example of how this actually works. And then, so when talking about softfoot, as I mentioned, there are actually 4 different types of soft feet. The first one here we have is what's called a rocking or a parallel softfoot. And this is where a softfoot is present in just one foot of the machine. When you're checking it, It could show up as multiple, that's during a check, but there's only one present in the motor. And this is really the most common type of saw foot. We showed this one just a second ago in that previous slide with that rocking saw foot, right? And then the second one we have here is what's called an angled or a bent foot. So this is where the foot of the machine does not make full contact. The full surface area of that foot makes full contact with the base. This could be that the foot is physically bent, or again, maybe your base isn't flat where that foot is sitting. But either way, you're not making full contact with the base. Step shimming is a common practice to correct this type of saw foot. The third type we have here is what's called a squishy foot. And a squishy foot can occur from many things. One is you may have debris, dirt, paint, rust, shims being corroded, or even the base. And actually, a recent study showed it's actually more cost effective to replace the shims rather than taking them out and cleaning them. And that has to do with labor costs as compared to the cost of shims these days. And of course, that's assuming if there's any mechanics, millwrights here in this webinar, that you have those shims available when you're doing your alignments. It can also occur if you have too many shims underneath a foot. All right, so the way I teach and present this is, 3 shims underneath a foot is kind of what the book will tell you. We say 4 is good and 5 is okay. And that really depends on your facility, your precision maintenance program, engineers, and whatnot. And the problem occurs is, and I've seen it in the field. A lot of people on here probably have as well. You see 10, 15, 20 shims stacked underneath a foot. And the problem becomes when you start stacking a bunch of shims underneath the feet. If you think about it, between each shim, there's air gaps, okay? And what happens is it creates a spring underneath that foot. And so many times I see mechanics, millwrights, they'll go directly to that shim kit and start adding shims underneath the foot without checking what's currently underneath that foot. And the problem with that is, again, when you're taking shims and you're just adding them underneath the foot, you're not consolidating those shims down. You're adding more shims, creating more air gaps. So you can actually be creating a saw foot and not even know it. So it's a good idea to take those out, clean them, replace them, and consolidate them down. This will prevent that squishy foot. The fourth and final saw foot we have is what's called an induced saw foot. This is really common with pipe strain. In this saw foot, you'll see you have 2 saw feet as shown in the picture here, and they're on the same side of the machine. So you can see here we have the pump as the example. It's typically pumps have the piping on it. So why is saw foot a problem? First of all, saw foot should always be performed first, all right, before you start aligning your machines. So basically, the goal here before you start, you try and move the machines is to try and get that machine flat. So if saw foot is present and it's not corrected, you're constantly going to chase your tail in the field. So I see it all the time. They skip the saw foot, takes too long, don't want to do it, whatever the case may be, but they skip it. And the problem is maybe they do overcome it. They don't fix the saw foot, but they're able to get it aligned. And what happens is when you align the machine, you're in the live move mode using a laser, and you get this smiley face. So your shaft center lines are centered while the bolts are loose on your machine. But then when you begin to tighten your bolts and you get to that foot or feet that has a saw foot, you then lose your alignment. Then that smiley face then becomes a sad face. So again, you're remeasuring, you're chasing your tail, and it makes for a very, very long alignment process. So what are the consequences here? So as I mentioned earlier in the webinar, the technical definition here for saw foot is actually internal misalignment. So when you tighten a foot with the saw foot, you not only lose the alignment, as I just mentioned, but you're also putting strain and stress not only on the machine frame, but all of its components as well. So when that frame becomes distorted, it causes its parts to also become distorted. And we're talking shaft, bearings, seals. So this is why we coin it as the term internal misalignment. And this then, of course, leads to symptoms such as vibration, also causes increased energy consumption, long-term damage, and even failure.